All right. So here we have 7A. So we started our discussion with parallel plate capacitor, and this is the equation of to calculate the capacitor. If we rewrite this equation, Q will become C times V. Okay. So this is a very important slide because this is our starting slide. If we understand this slide, the rest of the concept will be very clear. One of the question may be from this slide even, what will happen if we change these parameters, okay? Epsilon A and D. So you may think that this is very easy, but it's not going to be that easy. We will see in the question, but the idea would be what will happen if we change any of these parameters. We have to relate these changes with this diagram. Okay? We have to relate what happened if we change epsilon A or D for a MOS cap or parallel plate capacitor. What is the effect on this plot of that kind of change for epsilon A or D? So that's why it's a very important slide. You need to understand this slide and try to relate it with a charge distribution. All right, so next slide. Our objective, how can we change the resistance? Here we have another slide about parallel plate capacitor and the Venn diagram of the material. In this particular case, um, obviously they are very simple concept. If we have a metal, we cannot change the resistance, but how can we change the resistance? The question is, what is the question, right? What is the question? So this is our issue problem. If we use metal, we cannot change the resistance. What, how can we change the resistance of any of this metal plate? That you need to understand that, and you need to explain it in terms of um, in terms of carrier concentration and also the Venn diagram. So that's the continuation of the previous what we discussed. How can we change the resistance? And another very straightforward question may be that why do we need to change the top one or bottom one or all of the above and etc. So which one should we change and why? This, in this parallel plate structure. Now next is the MOS structure. Actually, that would be the solution from this previous slide, that we have to create a MOS structure. And why do we need to create a MOS structure? What is the objective? How does it relate with the objective of this course? That we have to use a MOS structure. How does it relate with the objective of the course? And what is the objective? Objective is to change the resistance. The other way to state that question, if we how the semiconductor helps to change the resistance. So that's the MOS structure, and this is the comparison between the parallel plate capacitor and the MOS structure. This slide is very important. So there will be a question: why Now, if we change the volt if we change the voltage for a MOSFET, what kind of change that that we will observe for the bottom plate? What kind of change of charge that will be observed in the bottom plate? So that's another thing. And also about threshold voltage, what is the significance of threshold voltage? All right, so that's the end of slide slides from 7A. Any question? Do you have any question?
Sir, could you please reiterate regarding how MOSFET is responsible for changing resistance?
How? What? How?
How MOSFET is responsible for changing resistance? Could you please reiterate that?
Now, that's the question. You have to find the answer.
Oh, all right, okay.
Okay. All right. Again, from the very first slide, what will happen if we change epsilon A or D, and how does that change will affect Q and V? This one, actually, this one, and this one also. How can we change the resistance of one of the parallel plate in this structure? We have to explain it in terms of uh, carrier concentration, then Venn diagram, etc. Now, next one would be, why do we need to use a semiconductor in a MOS capacitor, and how does it relate with the objective of this course? Next one, this table and this plot. If we change the voltage for a MOS cap, how the charge changes. Okay. All right then. I think that's about it from 7A. Anything else? And also about the threshold voltage. What is the significance of threshold voltage? So, out of all these possible questions that I mentioned, I will be. Uh, I I'm not going to ask you all the questions, but these are the uh, these are the questions that you need to focus. Okay? So I may ask something similar to this concept. Anything else? Any other question? If not, let's move on to 7B. Okay, again, this slide is very important. This one would be you know about the threshold voltage. Now, what is for the FET structure? Why can't we have a vertical current? Why the vertical current is zero? And if the vertical current is zero, why are we applying vertical voltage? These are the thing you need to understand. Okay. If we cannot have vertical voltage, uh, uh, which direction the current will flow in a MOSFET? So what is the or other way to say, what is the possible direction of current flow? Next, we have this all this combination. You really need to know all this combination. Okay. So what I can do, I may provide you a particular combination and ask you whether it will act as a MOSFET or not. And you need to explain that in terms of current flow. And we also have two conditions. One is the turn on and off condition. Another condition is the current flow. So if you say yes, this structure will work as a MOSFET, you have to explain in terms of equivalent circuit, current, and etc. Also, uh, the vertical voltage, whether the charge is positive or negative, and then we need to show, you need to prove that it satisfies those two conditions. Okay, same thing, same thing, same thing. I don't think we have anything else in this set of slides. Okay. So just like this last condition, it satisfied whether it was on or off. And about the charges, like here we have negative, negative, negative. That means there will be some current flow in the top branch, and there will be no current flow in the bottom branch. Right. That's about it from this set of slides. Any question from this 7D? Now let's go to 7C. 7C will describe the operation of MOSFET. So here again, I may provide you a structure and a specific voltage, either low, medium, or high. You need to explain what will happen to the charge distribution, what will happen to the resistance, and what will happen to current. You need to explain in this form. You need to derive VGS and condition with VGD and VGS, then explain in terms of charge distribution for both source side and drain side, and explain the resistance, whether it will constant resistance or the resistance will be high. And then in terms of the resistance, you need to explain whether the current will be high or low, or constant or linear, whichever it is. Even if it is in saturation, why the current becomes saturated, and how the current will flow. Although this is a discontinuous, the charge is discontinuous, how the current will flow, and why the current will become constant. All right, this is also an important slide. Remember, this point is very important. On the left side of this line, or this um, point, uh, or value of VDS, I would rather say, on the point. The left side of that VDS is called linear, and the right side is saturation. Why it is linear? Why it is saturation? That. And also, you need to learn the movement of of, uh, of current and voltage for different VDS and VGS. I think we have separate slide for that, but that is also applicable for this slide. All right, the next one, obviously, this is the biggest one. As I mentioned, 50% of the marks will be distributed for this uh, on this slide. So there will be some of the boxes will be missing, and you need to fill up that blank. I don't know which one will be missing, but you need to figure. I mean, it will be all obviously visible, but you need to provide all these diagram like this with the diode, resistance, charge distribution, etc. And also maybe some of these equations may be missing, and some of the regions will be missing from vertical side and also from horizontal side, from this column, from these rows. You need to fill up the blank. That's all. The next and the last slide for this semester or for this course, you need to figure or find out the movement of current and voltage. Suppose if I say that the initial voltage and current is here, what will happen if I change VGS and VDS? Or what will happen if I change only VDS? Okay. So that these are the question patterns that you need to focus, and these are the concepts. Obviously, it covers the entire MOSFET syllabus, but you need to focus on these topics that we I just mentioned. One last thing, let's see what we have here. So this is just repetition of the previous slides, and also for all these concepts, all these ideas, you need to go through the PMOS also. Okay, because so far we discussed with NMOSes, and every time I do analyze or discuss NMOS, I also mention that the PMOS will be identical. Analysis for the PMOS will be identical. However, everything will be reversed. N will become P, P will become N, and again N will become P. Positive voltage will become negative voltage, and negative voltage will become positive voltage. Negative charge will become positive charge will become negative charge for the MOSFET analysis. So you need to understand those concepts also. There will be some questions for PMOS from PMOS because it's just identical. All you need to do is to change the polarity. I think that's all I wanted to discuss with you. Although I scheduled it for 2 hours, but if you don't have any questions, I'm done from my side. If you have any question about question pattern or anything else, any other concept, we may discuss that.
Sir, you said that in PMOSFET, then everything will be identical. So the charge distribution will also remain same, right?
Right. But charge polarity will, the only thing that will change is the polarity.
Okay, sir.
So N polarity of opposite for N silicon is P silicon. Polarity of opposite of negative charge is positive charge, and vice versa. Remember one thing, only one thing. Everything will be opposite. Everything will be opposite. That's PMOS.
স্যার ভোল্টেজের পোলারিটি কিছু অপোজিট হবে স্যার যেটা যে
Everything means everything. Okay, voltage, current, everything, charge. Okay. So obviously, majority of the question will be from NMOS, but there may be one or two questions from PMOS.
Sir, will there be any options?
No, there will be no option. At least the PMOS, you have to answer the PMOS if there, for sure. Okay, anything else? All right then. So I hope you have the recording. So if you missed anything, should be able to get it from the recording. Someone is recording this session, and he or she will upload this recording to the classroom. Anything else? So actually, I know you're scared about PMOS because I don't want to go through that. Only one sentence I think I can explain your fear about PMOS is because this is unknown for you. You are all afraid of unknown things. So it means that you are not adventurous. You don't want to take any challenge. You want life to be very easy, AI driven. AI is going to do everything for you. So when the robot will take over this world, and you will understand that what will happen. Your life will be boring, and you will lose all interest about your life. So that's why we should have something exciting going on all the time. How long can you live on Facebook? You cannot. You are already fed up. I know. I got the report from many different parts of the generation, yeah, different from different generation. They are all bored with Facebook nowadays. Okay. So what else? There's nothing else. So that's why you are so frustrated. You are so scared. If it is not in Facebook, your world becomes obsolete. Or but just to make this transition easy for you, at least what I can do from my part, I can say this table that you have to answer and which will carry 50% of the mark will be based on PMOS. So you have to invert everything in this table.
Sir, including the applied voltage, right?
In what?
PMOS, we have to change the applied voltage.
You have to do what?
It is the direction of the applied voltage, right?
Okay, remember one thing, just one sentence. Everything will be opposite.
Okay, sir, got it.
Okay, if it is upside,
Yes, sir.
uh, uh, in terms of charge, and charge means voltage is related to the charge also, right? If we reverse the voltage, charge voltage will also be reversed, and the current will also be reversed.
স্যার হোয়াট
Every-
অ্যাবাউট স্যার হোয়াট অ্যাবাউট স্যার আমরা যে ভোল্টেজটা অ্যাপ্লাই করছি স্যার ভার্টিক্যাল এবং স্যার হরাইজন্টাল, ওইটাও কি স্যার ডিরেকশনটা কি আমরা স্যার অপোজিট পোলারিটিতে দিব স্যার, নাকি এনমস এর মতোই স্যার?
answer, same answer. Everything will be opposite. Everything will be opposite. Now you answer my question. So that's the problem. When even I give you the answer, you do not understand. I have to specify every single point. When I say everything is opposite, that also includes voltage, current, charge, in silicon, p silicon, everything. Everything means everything. Whatever you can think about right now, current, it will be opposite because current is included in everything. If you think about voltage, if you are thinking about voltage, that is also included in everything. So everything will be opposite. All right, any other question? Okay, I cannot make it more easier for you. Okay, I already gave you all the details, all the description, all the hints that you need. Now you have to find the answer. Okay. So 50% of the mark in the final will be from this table. However, it will be for PMOS. And in order to convert an NMOS to a PMOS, you have to make everything positive, everything opposite. Okay. Even the diode that you can see here, it will reverse the polarity. Okay, and resistance does not have any polarity, so resistance will remain same. But charge will have polarity, charge will become opposite. Voltage has polarity, voltage will become opposite. Current has direction, that means it's a vector, that means it has direction. So direction of current will be opposite also. Remember, anything that that has polarity plus minus or left right direction, those will be reversed or become opposite. You can make anything opposite, something opposite that has two types of polarities, like north south, east west. Those are all universities, right? Anyway, it's a north south, east west, plus minus, left right, up down. So this has opposite terms. For each of the term, it has opposite terms. So that's why you can make it opposite. But you cannot change a magnitude. Magnitude does not have any polarity. Absolute value for anything. So when we calculate the vector, we have magnitude, we have direction. We can change the direction, but we cannot change the magnitude, because magnitude is always the absolute value. It does not have polarity, or it does not have opposite polarity for absolute value, but it has direction that we can make opposite. Okay, I'm not here to teach you the vector math. I think you already know this thing, and I think I have provided you enough hints, so you should be able to do it. And okay, anything else?
No, sir. Thank you, sir.
Okay, all right. So who is recording this session? Who is me? Sajjatul. Sajjatul. Okay. Where is Sajjatul? I don't see your name. What is your name again? MD Sajjatul MD. Oh, okay. So can you send this recording to me in email? I will post it. Okay. Okay. All right. If there is no other question, I think we're done for today. Yeah, I will see you tomorrow at 5. All right.
Thank you, sir.
Thank you.
Welcome.